composition of functions today too, which is not hard to do. Okay, do you guys know how to tell if something's a function or not? Kai, what do you think? Vertical line test. Okay, so Josh, do you think this is a function, yes or no?
Yes.
Well, because it passes the vertical line test, right? Sweet. Okay, so then I would write yes. All right, what do you guys think about the circle? Would that pass a vertical for what? Vertical line test? How many points am I touching? So no, fail. All right, you can only touch 1 point. So a circle is not a function. That doesn't mean you can't write domain and range. Any parabola, though, this is a parabola. Any parabola should be a function. This is just a line. I'm only ever touching 1 point with any vertical line I run through there. So any line should be a function. Now, let me see if you guys can do domain and range, little throwback. All right, so domain should go from left to right and describe your x values. I'm just going to have us do this in interval notation. What x values are you going to touch for every parabola? Like, what would the interval be? Heck yeah, negative infinity. I know it's pointed down and you don't have a huge window of this graph, but this arrow, it's pointed down, but it would go to the left forever and you would cover every x value. And the other side, it's pointed down, but it would point to the right forever, so you would cover every x value. Okay, now the range, you should go from the bottom of the graph to the top of the graph when you describe the interval. We're talking about, so domain, sorry, I should have written that. Domain is x, range is going to be y. What is the lowest possible y value on this graph? Exactly, so pointed down forever, so you would want to start your interval at negative infinity. Okay, so from the bottom to the top, do I stop touching this graph? At what point? Or at what y value? 5. So then that's where you would stop your interval. Now, because this is a connected graph, right, we actually have a point right here. I'm touching the number 5. This would have a bracket on the interval. You never have brackets on infinity, only for plain numbers. But in this case, I'm going to have a bracket on 5 because I actually touched that point. Okay, the circle, totally not a function. But if I was trying to describe to you the possible x values, what's the first x value you touch? Negative 4, right? This is the right here. That's the first point I touch. That we're going to have a bracket because I actually have a point there, negative 4. Okay, the entire time I'm sliding this direction, I'm touching points on this circle somewhere until I get to this point right here, and then I would go right off the circle. So what's the last x value I touch? Same thing, is 4. Well, not the same thing, sorry, the other was negative 4. All right, now, if your circle is centered at 0, 0, which this lovely guy is, right, that's right in the middle, the domain and range should be the same. So you'll notice this. For the y values, the first y value you're going to touch right here at the bottom is negative 4. And then I'm continuing to touch part of the graph all the way till I get to the top of the circle here, which is at positive 4. So the range is actually identical as long as it's centered at 0, 0. If it's not, then those can be different. All right, what would you tell me for the domain for the line? What are the possible x values for the line? Yeah, right? This goes left forever, this goes right forever. You cover the whole x-axis, negative infinity to infinity. Range is actually the same. This end goes down forever, this end goes up forever, and so you cover all the y values, and that's true for any line. All right, now my next graph. Does anybody remember what kind of graph this is? Do you remember that shape at all from this semester? Yes, this is a cube root of x. I could write you the equation. I'm not going to, but this is a cube root. The cube goes a little bit differently, but this is a cube root. So would this be a function? Just yes or no? This is hard. This is a function. Right in here, it almost looks like a little bit of a vertical line. These numbers just get really close here. It's never vertical. There's like a twist in the middle there, so it's not actually vertical. It does pass the vertical line test. They're just like really close together, but it does pass the vertical line test. So any cube root should be a function. Now, this is extremely similar to the line. one of these sides goes left forever, one goes right forever. So you would cover every single x value. And then the range, I know this is tricky because it kind of looks like it's flat. This does gradually, this side would go down forever. So you would cover all the y's. This side would gradually go up forever. So this is also, negative infinity to infinity. All right, now, this would be like a piecewise function. Or it's not okay, never mind. This is not a function. Sorry, spoiler alert. I just ruined that. So this fails the vertical line test because like right here, I'd be touching 2 points. If you ever touch more than 1 point, you're not a function. So this is going to fail the vertical line test. So it's not a function. Now, just because it's not a function doesn't mean you can't do domain and range. So I'm not touching any part of this graph until I get to what x value? Go from left to right. What's the first x value you touch? -5. All right, so little bracket, -5. Now, these are just arrows, right? These are just going to go to the right forever, so we're not going to stop at a specific value, so this is just going to go to infinity. Can anybody tell me the range for that graph? What do you think? Exactly. Just one of the ends goes down forever, this end goes up forever, you'd cover the entire y-axis, so negative infinity to infinity. Some of these graphs are a little tricky. All right, now I got one more graph. Anybody know the shape, what this one would be? This is exponential decay. Excellent. All right, now, is this a function? For sure. This passes the vertical line test. I know this gets really close to the axis, but you're not ever going to touch more than 1 point, so this is a function. Okay, now, this one's a little weird, because remember, if you have exponential growth, this one's decay, either one, they approach an asymptote, but they don't actually touch it or go over it. So, this gets really close to 0, but technically it doesn't touch it or doesn't go over it. So when I write my domain here, the domain is easy. This is just negative infinity to infinity, because this side's going to go left forever, this side's going to go right forever. The tricky part for exponential functions is going to be the range. And that's going to be, you're not going to touch any part of that graph till you hop over the x-axis. It looks like it's right on it, but it's technically not. It just gets smaller, 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 but it never becomes 0. So you actually use a parenthesis. You don't use a bracket here. So the bottom of that graph would be 0. And then all the y values, everything else goes up forever on that left side. So you would cover every y value to infinity going up on the left there. All right, is anybody having a question? The rest of this we're going to do a little bit more algebra type skills. Bless you. Okay. I don't know what that was. All right, composition. Did you guys do composition first semester? Because I think some teachers did and some teachers didn't. So we're revisiting this because we should have done it first semester. I did it with my class. Sorry if you've already seen this. Okay. Now, composition of function G with a function of f. This is how you write it. F and then a parenthesis G of x. Okay, so maybe you did do this first semester. Okay, good. We're going to review this because we're going to talk about inverses. That's the ultimate goal in this little bitty three lesson unit is to talk about inverses, but you have to know how to do composition to do inverses. Okay, and it's defined as f composed with g of x. The other way you can write this is f and then, oh no, forgive, how you would read it. F of g of x is how you would read it. The other way you can write it is the bottom line here. This is f, and then it's got like it's like a weird little open circle. It almost looks like a multiplication symbol, but it is actually like an open circle G. These two would be in parentheses, and then the X would follow. So that's F composed with G of X, or F of G of X is usually how I read it. And we're going to work on how that works out algebraically on the back with some actual examples. Okay, now, I promise, this is not hard, but these are like two problems in one. And you might want a calculator for these questions, but we're going to run through these real quick. It's not hard, I promise. All right, now, my preferred notation, I like to write the f of g of x. So I'm just going to write both, so you guys can use whichever one you like better. So the way this works, whatever, if you're in the little, they call it fog notation sometimes because it looks like a little O. So if you're in that notation, whatever is closer goes first. If you like the other notation, you work from the inside out. But this is basically two problems in one. So up at the top of the page, they're going to give me two different function rules. One of them, these are both just lines. I have 5x plus 4, and I have x minus 3. Okay, so literally all this means, we're just going to start with the g function. So I'm going to evaluate g of 6. So I'm just going to start with that. So up in the directions, it tells me g of x is x minus 3. All you have to do is everywhere you see an x, you replace it with the number or variable or whatever they tell you. So you're just going to put in a 6. So this is x minus 3, so I would write this as 6 minus 3. The left side is just notation. It does not, you don't solve for g or anything like that. Just 6 minus 3 would be 3. Then what you do is you replace this for the g of 6. So it's two problems in one. And what you're going to do, you're just going to plug in 3 to the f of x function, and that'll give you your final answer. So I plugged in 6 to the g function, and I got a 3. So g of 6 is 3, and I'm going to take that 3 and plug it into the f of x function. Just everywhere I see an x, just replace it with a 3. That one's the 5x plus 4. So then I do 5 times 3, which is 15, plus 4 is 19, and then that's my answer to the question. It's just two problems in one. So if you have this notation, this is g of f of negative 7. If you have this notation, whatever is closer goes first. If you like the other notation, you would write this as g of f of negative 7. Just work from the inside out if it's in that format. So what it means, just first thing I'm going to do, I'm going to plug in negative 7 to the f of x function. So everywhere you see an x, I'm going to plug in negative 7. Okay, let me think about this. 5 times negative 7 would be negative 35, plus 4 would be negative 31. Then all you're going to do, this gets plugged in place of that f of negative 7. It's equal to negative 31. So then we do g of negative 31. Now the g function up here is just x minus 3. So it'd be negative 31 minus 3. So negative 34 would be my answer to, that would be my answer to the question. It's like two problems in one. So when you compose, you're going to plug something in twice. Now, you can, in this last one, little example, compose a function with itself. So this just means we're going to plug both of our answers into the same function. So first I'm going to plug in 8 to the f of x function. So f of 8 is just, we're just going to do 5 times 8 plus 4. It's going to give me, what, 44. And then the only difference here, I'm just literally, I'm going to plug that back into the same function rule. So we're just going to do f of 44. So I would do same function, 5 times 44 plus 4. I don't know what that is off the top of my head, forgive. 224. Is anybody having a question? It's not horrible. Okay, now I have some little bit of throwback, a little absolute value, and a little square root here, but I promise these are all nice numbers. So I wrote this in the other notation. So whatever's for inside goes first. So if I do f of negative 10, I would do 3 times negative 10 in the absolute value plus 2. Okay, now in the absolute value, what would you put in the absolute value there? Would you multiply it first, or would you just change it to 10, or what would you do? In this case, it doesn't. If we were adding or subtracting, it would matter. It doesn't matter here, but technically, you should simplify the absolute value down to one number just really quickly. This would be -30. And then once you get that down to one number, it acts like grouping symbols, like parentheses. Then you would take your absolute value. Absolute value just makes everything positive. So this would just become 30 plus 2. And I know I wrote out way more work than was necessary there, but that would be 32. Now, that's F with -10 plugged in. Now, we're composing this, so I got to plug this answer into the G function. So then we'll do G of 32. Now, my G function up here, this is all under the square root, would be 32 plus 4. So kind of like absolute value, the square root acts like a grouping symbol. You should get that down to one number and then take the square root. So this is going to be square root of 36. Now, I did not introduce the square root into the problem, right? It was already there. You did not take a square root of both sides or anything like that. So you do not put a plus and minus in front of this. This would just be 6. I did not introduce the square root, so you do not put a plus and minus. So if it's just square root of 36, it's just positive 6. Okay, let's try another one. So this one, I've got the G of 77 on the inside, so we're just going to start with that. So in the G of X function, everywhere you see an X, we're just going to replace it with 77. All right, so under the square root, get that down to one number first and then take the square root. So I'm going to add 77 and 4. So I'm going to get 81. So same thing, the square root was already in the problem. I did not introduce that to solve it. So what's the square root of 81? Just 9, right? Okay, once you got that, you're just going to take, and we're going to plug 9 in to the f of x function. So I'm going to do f of 9. Now, this is not really going to make a difference because it's a positive number, that you've got an absolute value there. But you'd have absolute value of 27 plus 2, which would just keep it positive 27 plus 2, and my answer would be 29. It's just two problems in one. And the last one, we're going to do composition. So this is going to be the same function. We're going to plug this in. So I'm going to do G of 3,590, I don't know why I just wrote that wrong, 96, which would be square root 3596 plus 4, which is going to be the square root of 4,000. Does anybody know the square root of 4,000? I don't know why I just wrote 4,000. I should be fired. Okay, square root, I'm sorry. Square root of 3,600, I cannot add apparently. That's super basic, I'm sorry. Does anybody know square root of 3,600? 60, okay. Now, we're just going to repeat the process. We're just going to plug it back in. So then I'm going to do G of 60, fail. And that is correct, I'm pretty sure. 60 plus 4, so then square root of 64 would end up, again, don't introduce plus and minus unless you introduce the square root. The square root was already there, so it's just 8. All right, does anybody have a question? Bless you. Okay, now, you plug numbers in, you get numbers out, right? So we plug numbers in for all of those questions. Now I'm going to plug some equations in, or some variables in. So if I plug numbers in, I get numbers out. If I plug variables in, I'm going to get variables out. All right, here's how this works. If this has an x, like I did the f composed with g with numbers, right? We're going to do this with x. This is the same as f of g of x, if you like that notation better. G of x is equal to x plus 3. If you're going to have an x there, your answer is going to be variables, okay? You're going to take this and you're going to plug that expression in place of x in the other equation. So I'm going to do f of this expression, which is x minus 3. So what you do, I have the 5. Everywhere I see an x, and I'm just going to use a different color to show you this, I'm going to replace it with the entire g of x function. So I just replace it with the x minus 3. This is a little different than what we just did because this will probably, unless it's some weird fluke thing, this will have a variable in the answer. So just simplify this like you would normally simplify something. So just a little distributive property, so 5x minus 15 plus 4. So this would simplify to be 5x minus 11, and that expression would be your answer. If you plug variables in, your answer is going to have variables in it. It's not going to simplify to be a number. And then the question right next to this almost looks identical, right? But this would be g of f of x, which what that means is we're going to take our f of x function, and everywhere we see an x in the g of x function, we're going to replace it with that. So I'm just going to grab a different color here. So the g of x function, I'm plugging in 5x plus 4. That's where the x was at. And then minus 3 was the rest of that. Literally all I can do here, I don't have any distributive property or anything because it was just x minus 3. So I have here 5x plus 4. You could skip that step if you wanted to. Minus 3. The only thing you can do there is combine the 4 and the negative 3. So this would be 5x plus 1. That expression would be my answer. Is anybody having a question? Okay. Now, this is very similar for these two. So these are the two same functions, but I wrote them twice just to kind of show you what I'm going to do. So g of x is on the inside. So this whole thing gets plugged in everywhere you see an x. So when I rewrite this, I'm throwing things. Okay, I'm going to write 3, and then in place of the x, you write the entire g of x function. So it's x squared plus 2x minus 8. And then don't forget it was 3x minus 1, so I'd have this little minus 1 on the end. All you have to do to get your answer, just simplify if you can. So a little distributive property, you got 3x squared plus 6x minus 24 minus 1. So I've got 3x squared plus 6x minus 25. If I simplify, that would be my answer. Okay, now I'm not going to lie to you. This is the worst possible scenario you would have to run into. This is g composed with f. The reason I say it's the worst possible scenario, I have in the g function 2 different places where I have x. So I have to substitute that expression in 2 different spots. And the reason I'm saying this to you is going to be tricky is because that first spot is x squared. So we're just going to have to do a little FOIL. It's not hard. It's stuff that you guys have been doing all year. So instead of x squared, I'm going to substitute in that 3x minus 1. That would be squared. Then I would have plus 2. And then I have to also replace that x with the 3x minus 1. And then we had that minus 8 on the end. So just separating it out. Now, the most annoying part probably of this whole thing, don't forget when you square something, that first term, you can't distribute that exponent, right? Because you're going to mess up the middle term. You have to do like a FOIL or box, whichever one you like better. But just write it twice, because if you don't, you're going to miss the middle term and that'll mess the whole thing up. So let me just write this out here real quick. We'd have, let's see, 9x squared minus 3x minus another 3x, and then plus 1. So 9x squared minus 6x plus 1. And I'm just going to drag this down here, and I'm going to do a little distributive property as I do it. So this would be plus 2 times 3x would be 6x. 2 times negative 1 would be negative 2. And then I'm just bringing down this negative 8. And then to answer the question, we're just going to combine like terms if we can. So let's see, I've got a 9x squared. Now, this doesn't always happen, but it does here. There's a negative 6x and a positive 6x, so those actually cancel each other out. And in terms of the numbers here, I have 1 minus 2, so it'd be negative 1 minus 8, so it'd be negative 9. And then you may be tempted, right? I could pull a 9 out in front. I could factor, don't factor, just leave it like this. Don't try to factor it. We're just trying to write the composition, so don't need to factor anything. We're not solving anything. We're just multiplying it out. Is anybody having a question?